Hello, hello everyone. This is the lecture series of Operation Research subject. This is lecture number 4, and the code of this subject is ME405. And this is unit number first. For my introduction, myself, Rahul Kumar, Assistant Professor of Department of Mechanical Engineering, Suresh Gyan, Vihar University, Jaipur. And today, I will teach about the problem related to simplex method. Yesterday class, I will give some introduction about the simplex method, and I will solve one problem related to simplex method maximization profit problem. Here are problems are divided into two groups. First one is maximization problem, and second problem is minimization of the cost problem, right? Or minimization of the raw material. And these are some the previous class. One is here. The simplex method uses a systematic strategy to generate and test candidate vertex solution to a linear program. And the simplex method is used to eradicate the issues in linear programming. This is programming not referred to a computer programming. This is the programming related to solve a complex variable problem into a simplex by the simplex way. And this simplex method is able to evaluate whether no solution actually exists. Means in the linear programming problem, three types of methods are present here. First one is graphical method, second is simplex method, and third one is sensitivity analysis. But in graphical method, only two parameters are solved. But in the case of variables, more than two problems we can solve by the simplex method. And the student examine the feasible sets adjacent vertices in sequence to ensure that at every new vertex. Means in the simplex method problem, the student can able to understand the two or more variable problem in a very simplex or in a very simple way, right? For the simplex method, and this is the some introduction about this. And most real world linear programming problem have more than two variables. Have more than two variable. In the case of last method, this is the graphical method, and are thus too large. For a graphical solution procedure, a procedure called the simplex method may be used to find the optimal solution. May be used to find the optimal solution. May be used to find the optimal solution and the simplex method is actually an algorithm or a set of instructions which examines corner point in a mathematical fashion until the best solution you will get here. Higher profit or lower cost is found for this method, and computer programs have been generated with as many as several thousands of variables, but it is still useful to understand the mechanics of algorithm. Mechanics of the algorithm means it provides a good way to solve the very complex problem related to one company obtain different types of products, just like the one wooden company make a three types of products, just like the bed, chair, and sofa, right? So how to solve this problem in the best way? This type of approach it will give by the simplex method, right? So this is a very easy method for solving a difficult problem. And in the next slide, we will define the converting the constraints to the equation. In the first step of the simplex method require that we convert each equality constraint. We convert each equality constraint in an linear programming formulation into an equation. This is this constraint just like as a this is a similar to equal and less than or greater than or equal to. In this problem, less than or equal to constraints can be converted to equation by adding slack variables. These slack variables are depend on the means how much product obtained by the factory. If factory obtain four product, then the slack variable are here four, and the select variable are here four. So slack variable depend on the company policy, right? This is the and and it will show by the example number 10.1, and this is the example number 10.1. This is a clear furniture company. This is a product mix problem was formulated using linear programming. Was formulated using linear programming in unit 9 as follows. The maximum profit is here. This is the one maximum profit function. This is the z equal to 7x1 plus 5x2. Subject to these two type of constraints. These are 2x1 plus 1x2 less than equal 10. This is the less than equal 10. And for the second case, 4x1 plus 3x2, this is the less than equal 24. To convert these inequalities, constraint to equalities, we have add slack variables. So here constraints are only two. Here constraints are only two. This problem we can easily solve by the graphical method, but we adopt a approach to solve this problem by simplex method here. To convert these inequalities constraints to equalities, we add two slack variables. These slack variables are just like S1 and S2 to the left side of the inequalities. What is the left side? This is the left the inequalities equation of the constraints or inequalities equation are 2. So the first constraints becomes just like a 2x1 plus x2 1x2 plus s1 equal to 10, and the second becomes 4x1 plus 3x2 plus s2 equal to 24. These are the two equations. So we can find with the help of simplex method the value of x1 x2 and s1 and s2 also. x1 x2 and s1 s2. So to include all variables in each equation, to include all variables in each equation, a requirement of the next simplex step, right? So we can return the equation in this form. For the next steps for the equation is just like a 2x1 plus 1x2 plus 1s1 plus 0s2 equal to 10. For the second equation, 4x1 plus 3x2 plus 0s1 plus 1s2 equal to 24. Since slack variables represents unused resources, represent unused resources such as time on a machine or mean hours available. Time on a machine on the mean hours available. They yield no profit but must be added to the objective function with zero profit coefficient. Then the objective function will become just like as a z equal to 7x1 plus 5x2 plus 0s1 plus 0s2. These are the two slack variables. Means slack variables depend on the number of constraints given by the company, right? So here the maximum profit, z function, these are the two constraints. So convert these equation and add the slack variables like this, right? So these are the modified form of the these three equations, right? So setting up the first simplex tabulation. This is the first simplex tabulation for the quantity in RHS. What the RHS value is here? 10 and 24. Here is RHS value equal to here the RHS value is equal to 0, right? For the maximum function case, maximum profit function case, then we convert a tabulation column for the simplify handling the equations and objective functions in an linear programming problem. We place all the coefficient in a tabular form. The two constraints equations for the example 10.1 could be expressed as these solutions makes variables. These are S1 and S2, and the quantity at the right hand side, these are 10 and 24, and the values of X1, X2, S1, S2 here. These are 10, 2, 24, 4, 1, 1, 3, 0, and 0, 1. Right? Then move to the any other steps in many management sciences. In many management science and operation research book, the initial solution is termed as a feasible solution, and it described in vector or column form. Then it will becomes like as a x1 x2 s1 s2. This is equal to 0 comma 0 and 10 24, right? This is the form of, this is a vector form of solution, right? And for the solution mix problem, often called the basic and linear programming terminology, as referred to as a basic variables. As referred to as a basic variables. In these examples, the basic variables are S1 and S2. In this examples, the basic variables are S1 and S2, and variables not in the solution mix are basic X1 and X2. In this case, are called the non-basic variables. Are called the non-basic variable. Of course, if the optimal solution to this linear programming problem turned out to be x1 equal to 3, x2 equal to 4, and x1 equal to 0, and x2 equal to 0 answer. Or then this matrix form is converted into x1 x2 x1 x2 equal to 3 4 0 comma 3 4 0 comma 0. Then x1 and x2 would be the final basic variables, while s1 and s2 would be the non non basic variables. So this question gives the two types of variables. First one is x1 and x2, and the x1 and x2. x1 and x2 would be the final basic variables, and x1 and x2 would be the non-basic variables. And some variables are just like as a artificial and surplus variables, right? So this is the solution of maximization problem. Here the x1 equal to 3 and x2 equal to 4. Put these values x1 and x2 and x1 and x2 in this maximum profit solution. This. So here 7 into x1. What will be the value of x1 equal to 3? 7 into 3 plus 5 into 4. 21 plus 20. This is the 41. 41 units. This is the maximum profit for this question is here, right? So this is the solution of this problem. This is very easy step to solve this problem. Then comes to the artificial and or surplus variables. And for the surplus variables gives the constraints in the linear programming problem a seldom. All the less than or equal to the variety seen in the examples. Thus, in this unit, just a common or greater than or equal to the constraints and inequality. To use the simplex method, each of these must be converted to a special form. Also, if they are not, the simplex technique is unable to set an initial feasible solution in the first tabulation. Tabulation is just like as a, this is the first tabulation value, right? Then now move to the minimization problem. This is the maximization problem of this company, right? So here the maximum profit is here, maximum profit function is here 7x1 plus 5x2, and find the value of x1 and x2. And for the minimization problem, here we reduce the cost of this material. We reduce the cost of the material and gain higher profit Now that we have illustrated a few examples of linear programming problem with the three different type of constraints, we are ready to solve a minimization problem using the simple algorithm. And minimization problem are quite similar to this minimization problem are quite similar to the maximization problem. And standard technique in linear programming is used for solve the optimization problem, right? And typically one involving a function and several constraints expressed as inequality for the minimization problem, right? The one significant difference involves the row. Since our objective is now to minimize the cost. The name variable to objective and now to minimize cost. The name variable to either the solution in each tabulation will be the one with the greatest negative number. Will be the one with the greatest negative number in the Cj and Z0, Thus, we'll be choosing the variables that decreases cost the most. Suppose the difference between the maximization and minimization problem is here. Maximization means maximize the profit of this company, maximize the profit of the company, and in the case of minimization, minimization the cost of the raw material, and reduce the cost of the different types of material, right? Just we will choosing the variables that decreases cost the most. In minimization problem, an optimal solution is reached when all numbers in the Cj minus Zj just the opposite from the maximization case. Just the opposite from the maximization cases. Here, these are the some steps follows to solve the minimization problem, similar to the maximization problem. Okay. Okay, sorry for interruption. These are the 5 steps to solve the minimization problem. First, all other simplex steps, as seen below remains the same, and choose the variables with the largest negative Cj minus Zj to enter the solution. Choose the variables with the largest negative Cj minus Zj to enter the solution also. And determine the row to be replaced. Determine the row to be replaced by selecting the one with the smallest non-negative quantity to pivot column ratio to pivot column ratio, and calculate new values for the pivot row. Calculate new values for the pivot row, and calculate new values for the other row. Calculate new values for the other row also. And in the last step, calculate Cj minus Zj values. In the last step, calculate the Cj minus Zj values for this tabulation if there are. If there are any Cj minus Zj numbers less than 0, if you will get any numbers Cj minus Zj numbers, these numbers are less than 0, then you will move to the first step again. Then you will move to the next first step again and solve this problem using different select variables, right? So this is the steps involving for the minimization problems. These are the examples. Let us begin to solve muddy river chemical linear programming formulation. For example, 10.5 using the simplex algorithms. The initial tabulation is set up just as in earlier example. We note the presence of a $m cost associated with artificial problem variables, just like the A1 and A2, but treat them as if they were any large number. They have the effect of forcing the artificial variables out of the solution quickly because of their large cost. Because out of the solution quickly because of their large cost, right? So just we uh, create a tabulation for this problem. Then CJ values is here $m, $0 and $m, and solution mix is here A1, S1, A2, and quantity for this question is here 1,300 and 150, and $5 here is the x1 equal to 1 and $6 is x2 equal to 1, and the select variable just like S1, S2 and A1, A2, right? Ej and Zi, right, for this. Then this is the 0, 0, 1, 0, and here 1, 0, 0, 0, and this is the A2 is here for the cell 0, -1, and this is 0 and 1 is here, right? This is the tabulation for the minimization problem. As you recall, the number in the row are computed by multiplying the C column on the far left of the tabulation time and corresponding number of each other column. Then ZJ for total cost. This is the M $1,000 and $0 300 plus M 150. This is equal to M into M into 1,000, 0 into 300, and M into 150. Right? This will give the 1,150 M. And for the ZJ column of X1 column, this is M1, 01, and M0. This is dollar M also. Then the CJ minus ZJ is equal to M dollar minus M equal to minus M plus 5. Then this ZJ for the X2 column is here M1 $0, $M1. This is equal to 2M. Then the CJ minus ZJ is equal to $6 minus 2M equal to minus $2M plus 6 is here. These are the values of related to CJ minus ZJ, right? So all our values are positive in nature, right? Then go to the ZJ for S1 column. This is equal to M into 0, 0 into 1, $M into 0, this is equal to 0. Then the CJ minus ZJ equal to 0. For the case of S2 column, ZJ is here $M into 0. Just all values are you have taken from this tabulation also, right? Don't know any other type of solution. Then ZJ for S2 column, this will give the $M 0 plus $0 into 0 plus $M into minus 1. This will give the negative result. Then the CJ minus ZJ, it will give a negative sign with $M. Then ZJ for this here gives the positive sign, and it will give say $M minus M equal to $0 is here, right? So these are the steps for this solution is here. So for the A1 row and S1 row, it will give say at 850 equal to 1,000 minus 1 minus 150. This is the solution steps. You can follow here, right? Just you see in this slide and note down this. And I can move to the next slide. This is the complication in simplex method. This slide shows the complication in simplex method. For the complication in simplex method, this will give the greater than or equal to constraints, greater than or equal to constraints and equalities instead of inequalities for constraints. Equalities instead for inequalities for constraints. And decision variable unrestricted in sign. Zero constant on the right hand side of one or more constraints, and some or all decisions variables must be integers, and non-positive constant on the right hand side of the constraints, and more than one optimal solution, that is multiple solutions, such that there is no unique optimal solution, right? These are the complications in simplex method. So this is the minimization problem. Sorry for interruption. Minimization cost problem. These are the complications in simplex method, and then formulation and linear programming model. The varieties of situations in which linear programming has been applied ranges from agriculture to zinc smelting. Zinc smelting. First is step involves. First step is determine the objective of the problem and describe it by a creation function in terms of decision variable. This is find out constant analysis. All things are already completed, I think. So formulation of this are the storage space. This is one more problem related to, just to note down this problem also. Formulation of linear programming model for form problem. This is a one example related to the agriculture field. The Agriculture Research Institute suggested the farmer to spread out of out at least 400 8,000 4,800 kg of a special phosphate fertilizer and not less than 7,200 kg of a special nitrogen fertilizer to rise the productivity of crops in his fields. There are two sources for obtaining these mixtures, A and mixtures B. Both of these are available in bags. Both of these are available in bags, weight of 100 kg each, and they cost rate 40 and rate 24 respectively. Mixture A contains phosphate and nitrogen equivalent of 20 kg and 80 kg respectively, while mixture B contains these ingredients equivalent of 50 kg each. Write this linear programming problem and determine how many bags of each type of farmer should buy in order to obtain the required fertilizer at at minimum cost. So this is also one type of minimization problem. This is also one type of minimization problem. So what is the solution step or adopt here? These are the solutions. So first, you identify the defined decision variables of the problem. with the number of bags of mixture. Number of bags of mixture A and B, and define the objective function. The cost of the mixture A and mixture B are given. The objective functions is to minimize the cost, just like the minimum function Z. Here is minimum function Z equal to 40x1 plus 24x2. And for this third step, state the constraints to which the objective function should be optimized. The above objective function is subjected to the following constraints also. Following the constraints also. And the formulations of these are the potash requirement, and this is the nitrogen requirement. So the question, it will becomes like a this. This is the question, right? So the maximum function for this question is here z equal to 40x1 plus 24x2 is subjected to a three constants, just like the 20x1, 50x2 greater than or equal to 4,800, and the 80x1 plus 50x2, this is a greater than or equal to 7,200. This problem you can solve with the help of graphical method also, and you can solve also simplex method, because here variables are only two in here, right? So this is the homework problem. You can solve this problem any methods, right? Then move to the next section. This is the what section is? Hmm? This is the MCQ problem. This is the MCQ problem section, and in this MCQ problem, the first question for the MCQ problem is here. Operation research emphasizes on the overall approach to the system. These characteristics of operation research is often referred as, means the characteristics of operation research which emphasizes on the overall approach to the system. This is system orientation, system approach, interdisciplinary team approach, and decisions. And the correct answer for this question is there. Just you think about this, and then I will give the answer of this question. The correct answer for this question is here, system approach. This is the correct answer for this question, right? System approach. This is the correct answer, right? And move to the next problem. Operation research cannot give perfect two problem. Cannot give this type of problem cannot give with perfect answer, right? So means operation research answer and solutions cannot give perfect answer. So this is the right answer, right? In the third case, third question, operation research simplify helps in improving the quality, clarity, look, and none of the above of the solution, but does not in perfect solution. But does not in the perfect solution. And what will be the right answer for this question is here? Quality. Improve the quality of the product and improve the quality cost of the product, right? Of the solution, but does not in the perfect solution, right? Then move to the next question. This is question number 4. Operation research involve attack of complex problem to arrive at the optimal solution. These are the answers for this question is here: scientific, systematic, both A and B, and statistical. Then for question for answer for this question is here: both B, A and B, scientific and systematic approach, right? For the operation research uses models built by quantitative measurement of a variable, a given problem, and also drives a solution from the model using of the diversified solution techniques. These are diversified techniques. These are two or more, one or more, three or more, or only one. What will be the right answer for this question is here? So this is D. B answer is this is the right answer. One or more approaches. Then move to the question number 6. A solution may be extracted from the model either by conducting experiment on it, mathematical analysis, and both A and B and diversified techniques. Here the both A and B. Right? MCQ problem for question number 7. Operation research uses model to help the management to determine its scientifically policies, actions, both A and B and none of the above. The correct answer for this question is here, both A and B. Right? This is the correct answer for this question. And the move to the next question. This is the 8, and this is a very simple question. Operation research is A. What is the operation research? Operation research is a science or art or mathematics. So the correct answer or mathematics. So the correct answer for this question is here D. D is the correct answer. Operation research is a science and art, right? And they move to the next question. This is question number 9. What have been constructed for operation research problems and methods for solving the models that are available in many cases. These are the scientific model, algorithms, mathematical model, and none of the above. And what will be the correct answer? For the question is question number C, mathematical model. Right? This is the correct answer for this question as well. Right? And for the move to the next question and last question of this MCQ. Which technique is used in finding a solution for optimization a given objective, such as profit maximization and cost minimization under certain conditions, under certain constraints, right? Queuing theory, quelling theory, waiting line, both and B. These are not related to linear programming approach. So these are the wrong answer. And linear programming, this is the right answer for this question. So these are the MCQ question for this today lecture, and move to the references. These are the some reference books you can use for the references. First one is Introduction of Operation Research, Hiller, FS and Lieberman, G.J. CBS Publishers. Operation Research, Taha H.A., MC Millan Publishing Company, and Foundation of Optimization, etc. CS and Phillips DT Prentice. These are the some reference books used to study the operation research. And in this today lecture, we have discussed about the simplex method maximization problem and two minimization problem related to simplex method, and one examples I have given for the homework and some MCQs question. So the next plan or next lecture, I will teach about the uh, sensitivity analysis related to the linear programming problem. Related to the linear programming problem, and thank you for the today lecture, and thanks a lot.